Good afternoon, folks, and welcome to the latest in our Global Mapper webinar series. You are in listen-only mode, which means that you can hear what I'm saying, but unfortunately you can't speak with me. During our presentation, we're going to be covering, as the title of my screen implies, some tips and tricks for Global Mapper. Those of you who attended last month's session, and by the way, I appreciate the follow-up comments that we received after that presentation. But those of you who were in last month's session were introduced to some of the lesser-known functions of Global Mapper and some of the tricks that we can use to make the software work more effectively and more efficiently for us. We're continuing with that theme today. We're going to be touching on a number of features and functions that you may know, you may not know, and hopefully providing you some information again to help you use the software to its maximum potential. Before we get rolling with today's presentation, I do want to mention a couple of things that we're going to be doing over the next month or two, some events that we're going to be attending. And if you are in any of these areas, we encourage you to stop by and say hi. We're going to be exhibiting. We're going to be doing some presentations. So again, if you're in the area, please try to make a point of stopping by and saying hello. First event is actually in the early part of January, January 9th to be specific. Myself and one of my colleagues are going to be traveling over to Saratoga Springs in the state of New York for the New York State Association of Professional Land Surveyors. That's a conference right there in Saratoga Springs. We'll be delivering a presentation. We will have an exhibit booth. We can show you all the latest and greatest from Blue Marble. So again, if you're in that area, Albany or the kind of the mid-state area of New York, I guess, please stop by and see us. Following month, February the 11th, we'll be sending a team out to Denver for the ILMF Forum, which is the ILMF conference, which is the International LiDAR and Mapping Forum. Very exciting technology, and certainly LiDAR is something that we're spending a lot of our time working on. With some of the future releases of Global Mapper, you're going to see some enhanced functionality as far as LiDAR is concerned, so it's a very appropriate conference for us to be attending. So those are just a couple of events coming up in the next month or so, and going forward, as we deliver these webinars, we'll continue to keep you updated on some of the events that we're going to be attending. As far as today is concerned, I did very quickly outline an agenda, which I'll show you. I should stress that this is merely a foundation. We will be covering a lot of additional functions in the software, where as we go through various workflows, various scenarios, I'm going to be talking about, again, some of perhaps the lesser-known functions of the software, some of the tools you may not be aware of. We're going to start by looking at some geocoding. We'll define exactly what geocoding is and how you can initiate a geocoding process within Global Mapper. We'll also be talking about some of our file organization mechanisms. Specifically, we're going to be talking about organizing some of your data into groups or map catalogs, two different ways of organizing multiple layers and making the workflow much more efficient. We will be talking about creating elevation areas. I tried to consolidate this bullet into a couple of words, and it probably doesn't encompass the entire extent of what's going to be covered. But basically, we're going to be using some of the contouring functionality to generate area features. Perhaps, again, a function that you're not aware of, but a very, very powerful function that's available within Global Mapper. We will be introducing scripting. Now, many of you have already made inquiries about when we would be delivering a webinar on this subject, and it's quite possible at some point in the future we may dedicate an entire webinar just to scripting. But for those of you who are just here to find out some of the basics of the software, I'm going to give you a very, very easy to understand and straightforward example of how a script works and how scripting can be used within the context of Global Mapper to make your workflow much more efficient. So we will give you a brief introduction to scripting. Very specifically, we're going to be talking about a function in Global Mapper for creating density maps. I'm going to be using some very interesting data from the state of California to create a density map, or what many people would describe as a heat map that shows concentrations of features. So another function that's available in all current versions of Global Mapper. We will be working with some land cover data. One of the online data sources that was quietly added for version 13 is obviously still available in version 14, is land cover data. There are some US-based data sets. There are also some European data sets that we can access through our online data services. And once those data sets are in place, we can generate some roughness and analyze that data for its suitability for particular applications. And we'll go through that particular workflow a little bit later. we're going to be talking about some of the raster options. In last month's session, we talked a little bit about some of the vector options we have, some of the characteristics that can be assigned to vectors. We're going to be looking at the raster side, some of the raster options. Specifically, we're going to be looking at some of the blending options. If you've got one or more raster layers, or I should say 2 raster layers, you can blend them. You can essentially establish a visual relationship between those 2 layers, so to speak. So we'll take a look at an example of how that works. Again, last month we looked at vectorizing. We looked specifically at vectorizing some topographic maps, a road intersection. We're going to look at a slightly different application of that function for slope data. And again, this is a question that we have gotten several times. In fact, this particular function was added after several customers requested this particular tool. So we're going to talk about vectorizing slope data. In other words, the angle of the terrain can be extracted, and area features can be created that represent the same slope value. So we'll use our vectorization process for that. And then I have a big et cetera at the end, because as I said, we are going to be touching on a lot of features and functions as we go through our various scenarios. So what I'm going to do is I'm going to fire up the application, and we're going to get started with our first tip or trick, if you like. And this example is geocoding. Now, geocoding is one of the tools in Global Mapper that's actually quite difficult to find. If I asked you to find the geocoding button or the geocoding function, you'd probably be looking for quite a while to find it. Once I show it to you, it makes sense. But I know when I was initially using Global Mapper many, many years ago, it was one of the functions which I struggled to find. I know the tool is in here, but I'm not exactly sure where it is. The function is actually in the search menu. And if you go to search without any data preloaded, you'll notice a find address function that's available. This is a web-based service that we offer where you can locate an address. It hits an online service. It will return a set of coordinates and show you where on the map that address is. And if I open that dialog, you will notice there is a button to allow me to geocode addresses from a file. In other words, this is like an address search, but it's an address search that locates more than one address. In other words, if you have a list of addresses. Before I initiate this process, I'm going to show you what data I'm going to be working with on my source data. This is essentially an ASCII file. I'm just going to browse into the folder, and it's a little customers file. This is hypothetical data. This is just some hypothetical customers, and obviously they have an address. They have a location assigned to them. The result of this process that I'm going to show you will be that each of these addresses will be plotted on the map. It will be represented on the map. There's obviously no inherent geographic information here. In other words, there's no lat long. We are going to create the lat long through the geocoding process. Now, typically when you go through a geocoding process, you're going to be referencing referencing the online service. There is also an option to use some preloaded road data. And that's what I'm going to do today. Simply to preserve our bandwidth because of our webinar, we're going to use some preloaded data. And I'm actually going to load up a shapefile. Actually, I'm going to load up a workspace that references that shapefile. And you'll notice now I have a road network, a very localized road network loaded up. And I'm going to plot those addresses against this road network. Now, if this is something that you're interested in doing, I should point out a couple of requirements. I'm going to use my info button in the toolbar. I'm going to select a road. And you will notice there's a number of attributes that are associated with this road. You'll notice specifically that we have left and right address ranges that are attached to each road segment. This is how the geocoding process works in the local context. For the left side of the road is an address range, and for the right side. So you will need to have the structure of your data in place before you can attempt to geocode against a local layer. The Tiger database, for those of you in the US, the Census Bureau's Tiger files are formatted to be supported by this function. So you can simply load up those Tiger files, geocode your address database, and it will work based on that pre-formatted Tiger data. So with this road network in place, I'm simply going to go through my search process. Again, going to find an address, and this time, again, as I referenced before, I'm going to geocode my addresses from file. And I'm going to go find the data that I was just looking at. Excuse me while I browse into some folders here. There's my customers file, and I'll click open. Now, our preview of that file confirmed it was a tab delimited file, and you'll see that's already selected here. I don't believe there were any columns in the first row of my file. I think I just started with the first address. Actually, no, I think I did have column headings, now that I remember. And we do want the geocode to loaded row data rather than an online database. So we'll go ahead and check that box as well. And we'll click OK. And immediately we have the results of that process, whereby we have the original attributes from that text file. And we also have now a latitude and longitude that has been assigned. And it's given me a level of precision. Because this is a hypothetical data set and everything's pre-configured, everything is exactly matched. In the real world, it's probably not going to be as clean as this, but in my world, this works perfectly. A couple of things I can do at this stage. If all I needed to do was establish the latitude and longitude for that address, I can simply export the results right to a file, and I'm done. Or I can create points from my geocode addresses, and I'm going to do that right now. I'm going to assign a point, basically put a point on the map. I'm just going to go with a generic point for the time being. And I'm going to click OK. And we'll close our dialog box, and you'll see scattered throughout my map are the point locations at which those features were added. You will also notice that if I open my Overlay Control Center, I have a new layer. My 12 features are in my user-created features layer, as you can see. And if I select one of these features with my Info tool, you will notice as I select it, I'm just going to right-click to select the point. It's an unknown feature in this case. Okay, which leads me and creates a perfect segue to something else I'm going to show you. Last week I mentioned, I talked about the ability to predefine styles for vector features, point styles, line styles, and areas. Now we're going to be dealing a little bit with area styles later in our presentation, but for now I want to talk about point styles. I mentioned this briefly last month, but I didn't actually follow through with it, so I want to spend a little more time on that, because here we have points, and these are customers. They're represented now by a little generic dot. I want to make them a little more apparent. I want to make them stand out a little bit more on my map. So I want to create a point style that is more prominent. The way I do that is within the configuration dialog. In the configuration dialog, as we showed you last month, there's area styles, line styles, and point styles. And with my point styles selected, I'm going to create a new type. I'm going to create a new type of feature. Before I do that, I want to use a symbol that's not one of my pre-formatted symbols. As you can see on this drop-down list, I've got things like arrows, and I've got lighthouses, and various other pre-formatted symbols. I want something that actually represents my customers. So I'm going to create my own symbol. If I choose the Add Symbols dialog, I can basically browse to any image, icon, or symbol file. And for this, I want to choose our trusty Blue Marble logo. And it's given it a name, Blue Marble logo, which is fine. And you'll now see now that it's represented, and that's an available symbol for me. I can assign that symbol to any feature type. So I'm going to create a new type. I'm going to call it Customers. And the symbol I'm going to assign to my customers is my Blue Marble logo, which is now available in this list. Now, you'll notice that this appears to be a little bit too large. I want to show you how we can change the size of that file in just 1 second. For now, I'm just going to click OK. The scaling option for any imported graphic file that you're using as a symbol, the scaling option allows you to define the scale factor. By default, it's a scale factor of 1. Just through trial and error, I was able to determine that a scale factor of about 0.3 works in this case. That will be just under 1/3 of the size, the original size. I could also establish this symbol at a particular height in ground units. In other words, where it's specifically located on the ground, a certain number of meters, a certain number of feet if necessary, I can establish that. And we'll click OK. And we'll click OK. Now, so what I've done is I've created a new feature type called Customers. I'm now going to take all of the features in my user-created features layer, which we know are all the dots, and I'm going to go to my options, and I'm going to assign those to that new feature type called Customers. And if everything goes according to plan, they will automatically be assigned my custom globe. So I can now create custom symbols, I can assign them to a type, and I can apply that type to any features on the map. It makes it a little bit easier to see. Now, this next function that I want to show you is a function that actually has been requested, not only by customers, but also by folks in the company, including myself. A more simple way for creating points. Now that we have our point style assigned, what if I want to just manually add a number of additional points? If I place my point on the map, I'm always going to be prompted with this Modify Feature Info dialog, and I'm going to, again, choose my newly created customers type. I'm not really concerned about the layer. I click OK. And I'll do the same again. Now, you will notice for the second point, it remembers my previous settings. If your intention is to create multiple points, you will notice that this Modify Feature Info dialog box always appears. Now, what I'm about to tell you is a trick within Global Mapper. If I hold down the Enter key on my keyboard, that dialog box immediately disappears. And you'll see I can now create points simply by clicking with my left mouse button. This is an extremely useful function for those of us who just want to add some points to the map without having to confirm every time. Again, you can't see this on my keyboard, but my finger is held right on my Enter key, and it automatically creates those points. You will see that dialog box momentarily appearing, but immediately disappears. Okay. Another function that we have in our search dialog is the ability to find and replace. Search and replace is what it says here. There is a standard search function that lets you search for particular features within a layer or within multiple layers based on a name, based on any of the attribution. But we also have a search and replace option, which is kind of a simpler interface, where we can define, based on an available attribute, a particular piece of text and replace it with something else. Now, in order for me to do this, I'm actually going to cheat a little bit. I'm going to bring up my feature info, and I'll notice the name field. Now, I want to change, in this case, every instance of the initials RD, and let's say in my case, I want to change those to the word road. I want to run that update across the extent of all data that's loaded. So I go to my search function, search and replace, choose that particular field name, which is name, and I'm going to search for the word road. Now, in this case, because we know there are multiple words that may come before the word road, I'm actually going to use my wildcard. In this case, it's an asterisk, as you can see, my wildcard character. And just type in road. I want to replace that with the word road. And once again, I put my wildcard, asterisk, and ROAD. And we'll search and replace text. Now, what you should see, and there's a piece of text right at the bottom of the map here, Marston Road. Once I initiate this process, that should change to ROAD. 61 features have been updated. And we'll close. Oh, in my case, it didn't. I think it's just the name itself that got replaced. Yeah, you can see the name. The actual label was not assigned as a name. But I was able to do it in the attribute table in this case. So, again, find and replace, a very simple way to universally update your attribute table by searching for a feature and then determining what that should be replaced by. As you can see during my sessions, I do create some messy maps, so I'm going to clean my slate here. I'm going to unload all of my data. Very useful keyboard shortcut. Hold down the Control button and hit the U button. It's asking me if I want to save any of my workspaces. In this case, I'm not that interested, so I'm going to click No, and we're back to where we started. As I mentioned at the start, we're going to talk a little bit about working with raster data. So in this case, I'm going to load up some different data. I'm going to go into my imagery folder, and I'm going to load up a workspace that has two layers. And those of you who have attended my webinars in the past will notice we use this data a lot. We have some imagery, some, I believe, half-meter imagery, as well as an underlying elevation model. First thing I'm going to show you is how we can adjust the shader pattern for our imagery. And in order to do this, I'm going to turn, for my elevation data. I'm going to turn off my imagery for the time being. There is a pre-formatted shader, which is called a daylight shader. And you'll notice when we select that daylight shader, it renders the entire image as a single color, accentuating the 3D effect, the terrain or the relief effect. And this can be toggled on or toggled off, by the way. There is a toggle button which allows you to turn on or off the terrain, the hill shading, if you like. And in this case, obviously, because we've used our daylight shader, it leaves everything else as a single color. Now, in my case, I want to change the default color for this daylight shader. I want to make it white, and for reasons you will see as we go through this particular workflow. For that, I'm going to go to my configuration dialog. I'm going to go to my shader options, and you'll notice the first option up here in the top left corner is the surface color for my daylight shader. And I'm going to change that to white, and click OK, and once again, click OK. And you'll notice now the color that was blue is now white. Now we're now seeing the hill shading a lot clearer. In fact, that's all that we're seeing. If I turn off my hill shading, my map is blank in this case. So let's go ahead and turn on our imagery again. Now here we have a situation, we have two raster layers, one sitting on top of the other. And obviously in the world of raster data, it's very difficult to work with multiple overlapping layers to essentially see through one layer to see what's underneath. As I have mentioned in the past, we have a very useful little image swipe tool that allows me to pull back my imagery to see what's underneath. But obviously that's like pulling back a curtain. It's not very useful for ongoing applications. So what I'm going to do instead is I'm going to adjust some of the options for my imagery layer by selecting it in the Overlay Control Center and clicking the Options button. Now, under Options, you'll notice there are options as far as dealing with raster is concerned to adjust the color intensity, the translucency, which is something you can work with if you're interested in seeing some underlying data through a particular raster layer. You can establish a specific color to be transparent, and the match of that color, whether it's exactly the color selected, can be adjusted based on exact or fuzzy. Or we have this blending option. In order to see the results of this, I'm going to pull my dialog box over to the right. This blend mode provides various ways in which two raster layers, or a raster layer and what's underneath it, can be blended. Now, you can go through these options and through trial and error see what the results are. Those of you who have used Photoshop or used any of the image applications will be familiar with some of these processes. In this particular example, what my intention is to essentially allow me to see some of that terrain information through my image, if you like. And for that, I find what works best is my multiply option. And when I choose multiply and click apply, I'm going to essentially visualize two layers simultaneously. And you can see, and the best way for me to illustrate this is to turn my elevation data off temporarily. Oops, I have to close this window, I'm sorry. We'll turn the elevation off, and you'll see it's a flat ortho image. Turn it on, and you can start to see that texture from that underlying elevation model. So I've given my imagery a really nice textural feel by essentially allowing me to see through to see certain elements of that underlying data. I can still see the imagery features very clearly. I'm not really losing too much in terms of the quality of the imagery, but you can see the shadows really provide a nice textural feel, and it's simply a standard underlying elevation model that lets me do that. And again, choosing that daylight shader, dropping the background, the daylight color to white, allows me to render the map in the way that you see right now. Speaking of the shaded relief pattern, for the time being, I'm just going to briefly turn off my imagery, and I'm just going to go back to the Atlas shader, which is our default shader. And you will see, again, as I had mentioned previously, the relief pattern giving us the shadow effect, which can be turned on or turned off. It can also be customized. The way that this shadow is set up by default assumes a sun angle of 45 degrees north of the equator, actually 45 degrees from north, which would be also 45 degrees north of the equator, essentially in a northeasterly direction, and the sun angle at a 45-degree angle above the horizon. And you'll see that if I click on the configuration dialog again and choose my vertical options, you'll see that setting right here. 45-degree altitude, 45-degree azimuth. That's the default angle of the sun, which creates a shadow, as you can see, in the southwestern slopes, if you like. If you need to customize that, if you need the shadow to be aligned in a different way, you can simply alter these values. So to see a drastic change, I'm going to choose a different azimuth. I'm going to go all the way to a kind of a western perspective, so the sun is kind of on its way to setting. And let's bring this down to about 30 degrees, and we'll just check out the results of that process. Just take a look at the shadow and how that changes on my map after I click apply. Well, obviously there's a lot more shadow here. We're getting close to sunset, but you can now adjust the light direction which causes that relief pattern, which results in that relief pattern, and customize it for your own applications. If you want to see, for a particular time of year, if a plot of land, maybe you're cultivating a crop, for instance, and you want to see if there's going to be shadow, it's going to be full sun in a particular year, you can enter the appropriate parameters and visualize that shadow effect right on the map. You will notice also for our vertical options there are methods for adjusting the light intensity, et cetera, et cetera, et cetera. So you do have a number of other options in this dialog box. So we'll go ahead and cancel that. Okay. We have in the past talked about generating contours. I want to show you one very specific function that can be applied after contours are generated. The contour function, by the way, is right under our terrain analysis menu, generate contours. Those of you using an older version of Global Mapper will find this function under the file menu. But with the release of version 14, we have consolidated a lot of these functions, and as you can see, we now have a terrain analysis menu, which includes our generate contours. What I want to do here is simply generate a couple of different contour layers for the purpose of showing you how the grouping process works. The first contour layer I'm going to generate is going to be 5. Actually, let's make it 10-meter contours. And I'm going to go with everything else. The defaults are all set. That's fine. I may want to change my description to reflect that. I'm just going to call it 10 meters. So we can differentiate if we create multiple layers. We can differentiate the different layers that we create, and we'll click OK. And you'll see on my map we have our contour layer created, 10-meter contour interval based on our elevation data. Now, as I've mentioned in the past, these contours that have been generated are essentially static vector features. They're not dynamic. They're not going to change as I zoom. But we can force that. We can essentially customize our setup so that it appears that our contours are dynamic. The way that I do that is simply by creating another contour layer. Again, generate contours. This time I'm going to generate a contour layer at 2 meters. And again, I want to change the description to reflect that. I just call it 2 meters. And click OK. And again, it's creating a new layer, a new vector layer with a contour interval of 2 meters. Now, we're going to, as you'll see in just a second, end up with 2 layers. As you can see, there's 2 contour layers. These obviously have something in common. They may be something that you want to manage collectively. By the way, in this case, I may also want to adjust the zoom level within which each of these layers appears. For instance, if I zoom in to a certain level, I may just want to see my 2-meter contours when I get to this level. And let's say I'm looking at my scale at approximately 1 to 7,000. I'm going to make that the cutoff point. So for my 2-meter contours, I'm going to set the zoom level within which these layers are going to be displayed. So right here, the second option, set what zoom levels to display the selected layer at. And I'm going to say below my scale of 1 to 7,000. I'm going to bring that down a little bit, actually 1 to 6,000. And we'll click OK. So those contours will not appear until we get to that zoom level threshold. My 10-meter contours, again, we may want to go between 1 to 25,000, and we'll just do 1 to 6,000 again. It's technically going to be a little overlap, but that's fine. And again, what you'll see as a result of this, as we zoom in on our map, the 2-meter contours will kick in once we get to that scale. And you can repeat this process and create multiple different contour layers for different levels as you zoom the map. As I mentioned, these 2 layers have something in common. It would be nice to be able to turn them off collectively. And obviously in this case I've only got 2 layers, but you may have a situation where you have multiple files, all of which display the same features that you want to control or visualize or turn off collectively. And the simplest way to do that is to simply select them in the Overlay Control Center, to right-click, and to create a group, to essentially group these together. Now, this is a very simple process. I'm going to call these contours, and I'm going to click OK. And what you'll see is a single checkbox that now lets me turn on or off all of the layers that are in that group. I can also expand and turn off individual layers. So I have collective control and individual control at the same time. Very, very useful, and if you're dealing with multiple layers, and I've seen many of your setups where you do have a lot of layers, this is a very simple way to organize your data into multiple layers. By the way, I recently had the question, okay, I've grouped these layers. How do I ungroup them? The way you do that is you basically reverse the process. You select what you want to ungroup. You go to your group option once again, and you simply delete this heading and click OK. The action of deleting the group heading removes the group, and you're back to individual layers again. Speaking of contours, and this is, again, a lot of my themes today come from recent conversations I've had with customers. What I'm going to show you now is a slight adaptation of the process of generating contours. I'm actually going to generate areas instead of lines. I'm going to click my home button to zoom to the extent of this layer. I'm going to go to my terrain analysis and once again generate contours. This time, I don't want to generate contours for every elevation threshold. I only want to generate contours for specific elevations. And in this case, the elevations in question are going to be a 100-foot contour, and I'm going to do another one in a second for 75. The important part here is I want to check this only generate contours box, because with this check, it's not going to have a contour interval per se, but it's going to essentially generate a single elevation line. Now, the other thing I'm going to do is I'm going to generate area features. This area feature tool is extremely useful for essentially creating a polygon or an area that defines everything above the specified contour. This is going to create a polygon that encloses everything that's above 100 meters. And again, we'll check that box and we'll click OK. And it will also, as you'll see, inherit the color from my legend that reflects 100 meters. So I now have generated areas that I can use for whatever analysis. Show me all of the particular locations, the point features perhaps, that are within this area, that are above 100 meters. These are not interactive features. Unlike every other vector feature, they can be modified, they can be exported in vector form in any of the supported formats. So it's an extremely useful function. I'm going to generate one more area elevation feature. This time I'm going to change my value to 75. And you'll see it will superimpose these right at the top. Once again, only generating contour at specified height and also generating areas. And we'll click OK. Oops, and I did it the wrong way around, which is fine. I'm going to adjust the order in my overlay control center. And we'll get to where we want to be. There we go. So now we have everything over 75 and everything over 100. What if I want to find everything that's between 75 and 100? Well, you'll notice if I select the 75-meter contour, well, it incorporates everything that's over 100 as well. So I'm going to have to use one of the tools, one of the advanced vector tools to achieve this function. Basically, what I want to do is select the two areas that are within the larger polygon, essentially the two areas that define areas over 100 meters. And I'm going to cut these. I'm going to use my cutting tool, my island creating tool, if you like, to essentially use these to define just what's between 75 and 100 meters. The way I do that after they've been selected is I go to right-click, and I go to my crop combine split functions menu, and I choose cut selected area from another area. This is my Add Islands tool. Now, once I select this option, I'm going to be asked to choose a parent. In other words, this defines the area feature from which what I've selected is going to be cut. So I just simply click anywhere inside this area, and I do want to delete what I'm using for the cutting purposes. I want to delete that. I want to leave holes, essentially. So I'll say, I'm going to say yes in this case, and there we go. We now have a single area feature that encompasses everything that's between 75 and 100 meters, nothing above and nothing below that area, that threshold. Okay. Once again, I'm going to clean up my map slightly. I'm going to unload everything. We don't care about saving, so I'll say no. I'm just going to refresh by bringing back my my imagery once again. I'm going to be working with the same elevation data set. And for this, again, I'm going to turn off my imagery. Now, one of the shader options that's available from this drop-down is the slope shader. And as you can see, the slope shader changes the legend and changes the visual characteristics of the map. It almost looks like what we had previously, which was our daylight shader pattern. But in this case, the darkened colors in this case don't reflect actual elevations, but reflect degrees of slope. As you'll see in my my elevation legend along the left side of my screen, These are now degree values. Obviously, the lighter colors are relatively flat. The darker colors relatively steep. What I want to do in this particular workflow is I want to extract specific areas of slope. In other words, areas that fall within a defined threshold. And the way that I do that is from within the Overlay Control Center. I simply right-click on the layer, and I choose Create Area Features. We did this last week in a different context. This week, or last month, I should say. This month, we're going to capture areas that fall within slope thresholds as opposed to specific colors. And you'll notice immediately in this dialog box that slope is my option. I'm going to adjust the threshold value, essentially the fuzziness value here, just to give us some kind of broader areas. I'm going to type a 3 in here. So above and below 3 degrees is going to be captured in this case. And I'm going to define this on a slightly smaller scale just to speed up the process. I'm going to draw a little box to limit the extent of what's going to be processed. That basically fills in my projection information here based on what I've manually selected. And I think everything else is fine. And I click OK. And what you'll see at the end of that process is essentially vector features that define the slope. And again, these can be exported in any of our supported vector formats. You can run an analysis to find all of the points, for instance, that fall within certain elevation thresholds. Here's my slope value, 15 degrees. My slope value is 3 degrees. So what we did is we took a simple elevation layer that typically would represent elevation above sea level. We rendered it as slopes, and then we captured those slope values, and now we can use them in an interactive way, given that they're in a vector format. Okay. And again, I'm going to unload all my data. Now, I showed you the process of creating groups. That's a very simple and easy to administer tool for collectively managing individual layers that share something in common. Maybe they're all the layers that pertain to a particular project site. Very simply add a group, and they can be turned off and turned on individually or collectively. What I'm going to show you now is a slightly more powerful version of that same tool where we create a map catalog. Under the File menu, we have this option to create a map catalog. I'm just going to call this catalog test for the time being. You can see I'm creating a .gmc file here. I'm going to save it, and I'm prompted with this dialog box. Obviously, there's nothing in here yet, so the first thing I may want to do is add some files. By the way, you can also create a catalog from within the Overlay Control Center by selecting the layers, use your right-click option, and then generate a catalog. Same end result. In my case, I'm going to manually add some tiles here. I have some imagery data, in fact, 4 tiles of imagery that I want to work with collectively. I select Open, and I've added those 4 individual JPEG 2000 files to my catalog. There are various functions that I can apply here, things like determining the visibility of this data relative to either a scale or a percentage size of your window. I'm just going to leave it at the default, and you'll see what the behavior of that is when we actually look at the map data on our screen. You can define what the maps will look like if they get beyond the threshold of visibility. You'll see in my case it will be a simple check pattern area features. I can add additional files if necessary. I can add all the files within a specified directory. Obviously, I can remove files as well. So this is now a collective layer, so to speak, but it contains a number of different individual files. I click OK, and it's going to load that up. And you'll see there are 4 individual tiles. However, in my Overlay Control Center, there's only one object. And I can turn it off. I can turn it on. I can go to Options, go back into this dialog box, and again, reset some of these parameters, add additional data, remove data. If there's raster layers present, I can also modify our rasters just like I did before. I still have control over those options, or vectors for that matter as well. I do have that ability, but now I'm dealing with one file. This really speeds up the processing for in Global Mapper for multiple files, especially these imagery tiles. If you've got multiple imagery tiles, it speeds up the rendering, it speeds up the processing. So it's an efficiency tool as well as a convenience tool. Now, as I showed you previously, this data has a finite threshold. In my case, I left it at the default. So you'll see as I zoom out, the maps themselves are not rendered, but this placeholder box indicating where the maps are located is now what's displayed. This works particularly well if you've got imagery, for instance, which really doesn't have a useful range, or has a very limited useful range. You don't need to see it too close. You don't need to see it too far out. You can define those thresholds by adjusting those parameters under the options dialog. So again, a catalog really makes working with multiple tiles very, very efficient and makes your workflow much more efficient as well. Okay, let's talk about scripting. I promised I would introduce you to scripting, so let's take a quick look at what a script is. I'm actually going to close out of the application here in just a second. Before I do, I want to show you one location where you can initiate a script. Obviously, this really doesn't mean anything in this context until I actually show you what a script is. But before I close the software, I want to show you an option you have under the File menu for running a script. So if you have the application up and running, you can initiate that scripting process right here. With that, let me go ahead and close this dialog box, and I'm going to show you a file. Now, this particular file that I'm going to show you, script symbol all the way at the bottom, is a simple little text file. If you're beginning a script, it's very easy to start the process just simply by opening up Notepad. It is an ASCII file, and you'll see mine has a .txt suffix, and if I open it, I've had this one pre-configured. Now, this script, basically what this is going to do for me is it's going to import a defined layer, which is an elevation layer. It's going to generate some watersheds based on the parameters you see here, and then ultimately going to export the watershed areas in a shapefile format in areas, and I'm going to generate a projection file. So this is a very, very, very simple example of what a script can do. Now, this particular script is actually going to be run without even looking at the software. I'm actually going to run this externally. Granted, the processing engine is still chugging away under the hood, but I'm not interacting with the software itself. If you want to build a script, you're always going to begin with this line, global mapper script version equals 1.00. Thereafter, there are a number of parameters you can establish, importing different processes that can be applied. The best reference is in the help documentation that comes with the software, and I believe it starts somewhere about page 230. It runs through all of the available commands that can be applied through a simple little text file such as you see here. So this example, as I said, is very simple. It's going to import a pre-existing DEM file, run through a process, and ultimately export a shapefile. Now, my fingers are crossed this works. Before I do this, by the way, I want to change my suffix to GMS, which defines it as a global mapper script. It's recognized as such. It's still an ASCII file. It's warning me about changing extension. I'm fine with that. And we're OK. Now, again, before we do this, I want to quickly show you the directory. This is my directory within which my elevation layer is right now. With my drums rolling, if I simply run this script, I should ultimately end up with a shapefile in here as well, generated from that DEM, generating some watersheds. So again, I could run this script within the application, but in my case, I'm simply going to double-click on the GMS file. And you'll notice my little hourglass implying that there's something going on. I'm not seeing the software. The software is not actually running, but I know it's doing its job. So it's initiated an import, gone through the watershed generation. Now it's probably at this stage going through the export, and if I open up my temp directory, not quite there yet, let me go ahead and refresh. It will happen eventually. It will generate there we go. It generated a shapefile for me. So I was able to generate a file from a source file going through a process. This is extremely useful for very simple processes like reprojection, where you define in the script what exactly the parameters are for the projection, and you simply let it run. You can hit individual files within a defined directory, so you don't have to point to each individual file. You can say all of the files within a specific directory, process them, export them as individual files. So really, there's a lot of flexibility in this scripting process. Now, to prove that this actually worked, let me fire up Global Mapper once again, and we'll go ahead and drop the shapefile on. And you'll see now there's my defined watersheds based on the script that I generated. So scripting, very, very useful tool. Now, I'm going to let you into a little secret that not a lot of people know. A good basis for creating a script is a workspace file, because a workspace file is essentially the same as a script in its structure. So for instance, I know I have a number of workspaces in here. Let me go into my imagery. Here we go. Here's my GMW workspace file. This is the file that I saved within Global Mapper to remember my settings, etc. If I right-click and open this in Notepad, you'll notice it actually says Global Mapper script right at the top. So a good way of creating a template for building your own script is to save a workspace after loading some data. Now, there's a number of other parameters in here, elements like defining a layout, but essentially it's the same process. You can change your suffix to GMS, and it will run just like a script. Okay, one thing I want to show you very quickly. We have an instance of Global Mapper running here. Let's say we're running a process where we're processing some raster imagery. You can run two instances of the same version of Global Mapper simultaneously. Quite a few people are not aware of this. So I simply click on my icon again, and I can run a separate process. This is extremely useful if you're, for instance, downloading some imagery and your version of Global Mapper is hung up doing that. There's no violation of the license by just opening up a second instance and then doing some vector work or doing something else, maybe running some processes simultaneously. So multiple instances of Global Mapper can be run simultaneously, allowing you to be doubly productive. Getting your work done in half the time. You can go home early. Okay, what's next? Let's very quickly look at the land cover option. I'm going to, again, unload my data here. I know we're looking at my clock and we're quickly running out of time once again. One of the available data sets that's pre-configured as an online data source is land cover data. This was added, I believe, sometime during the generation of Global Mapper 13. And you'll notice in here there's a number of different pre-formatted options. We have our North American land cover data set, land cover database for the US. We have our European land cover, slightly lower resolution, and then tree cover worldwide, again, slightly lower resolution. These are just some of the pre-formatted options. Can be accessed directly online. I'm going to open up the results of that. I'm obviously going to access the data itself. Let me go up a couple of layers. Apologies. Let me go to my desktop so I can find my data once again. And I have a couple of examples to show you here. I'll just go ahead and bring the Colorado version here. Now, this is a raster data set that defines a land cover. And here in Colorado, you can see colors representing a particular vegetation type, a little bit of urban area up here. I'm going to bring in a different data set, which is right around where we're located up here in the northeast U.S. And I'm going to redraw my map to show you the different color display here. So you can see different variations on land cover represented here. This is a raster data set. There is a legend available here on our map layout function. We can actually render a legend based on this color palette. And we'll click OK on this. And you'll see now, because of the colors here are defined as specific land cover features, you can see these now displayed on my legend, much like we would display a legend for our vector features. One of the processes that was introduced after making this land cover data available is a process whereby we can calculate roughness. Now, any of you involved in the wind industry will find this particularly useful. Roughness was a calculation that was developed to determine the level of friction that would be applied to surface winds based on the underlying land cover. And there is an available option now with a land cover data set loaded to right-click and create that roughness grid. And if I choose that option, brings a dialog box that allows me to establish which type of data I'm looking at. In my case, I know it's the U.S. National Land Cover. And it's essentially an elevation layer that's going to be created. So I'm going to choose a shading pattern. Obviously, I can change it after the data has been loaded, but it's asking me to choose a shader. I can also generate area features. This is going to be, as I said, an elevation, a raster elevation-like layer, but I can choose area features instead by checking this box. I'm going to specify the bounds of this again just to speed up the processing. Just going to choose a small area within my data set. I'm going to click OK, and we'll click OK once again. And because my slope shader was selected, it's rendered it as a slope. There we go. Now you can see we have roughness values generated. The elevation legend, I'm going to turn off my units of measure because they're actually not meters. But this represents the roughness value. Blue areas in this case would represent areas which are relatively free of roughness. So these would be open areas where there's no friction. The redder areas, in this case, we happen to know these are forested areas, would have a higher level of friction. So in determining the location for a wind generation facility, you can process this data, analyze this data to determine exactly where that optimal location would be. So roughness calculation, and again, based on the available online land cover data that we can download. Okay, let's talk about density mapping. And for this, again, I'm going to clean up my map by unloading my existing data. Frame of reference, I'm going to import a outline map covering the state of California, just to give us a visual perspective. The data I'm going to be working with in this case, and I'm going to quickly turn off my legend because it's no longer applicable for the data we're working with. The data in this case is actually a text file. I'm going to go to my desktop and quickly open up, oops, I have to close out of that, and open up the data so we can take a look at what we're going to be mapping. Webinar data. So here's a CSV file with some latitude and longitude values. And I'm going to expand it so we can see what's going on here. We have a station name. These are weather stations. Station name, we have an elevation. Then we have our latitude and longitude values, and then we have some climatological data. I'm going to be looking specifically at our precipitation. My intention is to generate a map that reflects higher instances of precipitation in the state of California. So there's multiple processes, multiple steps I need to follow to do this. The first step is obviously going to be to import this data. Those of you who have been using Global Mapper for a while will know that we can import this text file and generate a point layer, essentially, and that's what we're going to be doing. However, before we do this, it's important to note that in this case, my latitude and longitude values are not the first two columns, but they're actually the third and fourth. So we'll make a mental note here to skip the first two columns during the import process, and I'll show you where we're going to do that. Also, we'll notice that we do have a header column, if you like, a column with a row with our column headings. So just a quick preview of the data. We'll go ahead and close that file right now. We don't need to save it. And we'll bring up Global Mapper again. And we're going to go through an import process. In this case, we don't go through the normal open process. If you were importing pre-configured geospatial data files, we're actually going to go and import our text file. And there's the file I just previewed, our CSV file. You'll see our standard generic ASCII file import options dialog. Well, first off, I want to make sure that I'm only importing points. There are no lines or area features. I do not need to connect the dots. These are only going to be points. I know that my latitude is my first value, so I'll make sure that is selected. I'll also make note here that there are two fields to skip at the start of each line. In other words, my first two columns were the name and some other information about that particular weather station. So disregard those as far as plotting the points is concerned. My lat long starts at column 3. There are no rows to skip at the start. However, my column headings are in the first row. I'm not talking about elevation in this context, so we don't need that option selected, and we do want to include our attributes with this data. We want to include all of the attribution as well. We're confident that the Global Mapper will auto-detect our delimiter, so we're fine with that. So all being well, this will plot each point on the map. I happen to know that the projection parameters are geographic, and WGS84 is the datum in this case. So we'll just click OK through this dialog box, and we now have our points on the map. Each of these weather stations has now been plotted. And if I use my info tool, you'll see I have the additional data now added to the map. So what I want to do now is I want to generate a density map that reflects that precipitation value that I displayed previously. This works with any point layer, and this is kind of another hidden option. If you choose the point layer in the Overlay Control Center and you right-click, you will notice here an option to create a density grid. The density grid gives me various options in here. I'm going to be creating essentially a new layer, so I can define the name of that layer. The grid can simply be based on the clustering of points, and this is very useful for that specific purpose. If you want to generate a map that visualizes in a color pattern where the highest concentrations of point features are within a defined area, you'll simply use the point count. In my case, I want that heat map to reflect one of the inherent attributes, which in my case is my precipitation value. So my heat map, essentially, heat map in the different context, is going to reflect higher locations of precipitation. My search radius, usually the reformatted search radius will work. I'm just going to expand this slightly just to give me fuller coverage. I'm going to make this 20 kilometers for my search radius. And everything else in this case is fine as is. I can define the bounds again if necessary. I simply click OK. And eventually, I will see a heat map. Now I'm just going to adjust my frame of reference so I bring my outline down to the bottom. Here we have a heat map that reflects the precipitation levels within the state of California. It's a raster layer. You'll see it's expanded beyond the bounds of my my initial polygon. I could, if necessary, if I wanted to capture this, I could go through the export process and limit the export to a selected vector feature, which in this case I've selected my area. So I can clip it down during the export process, generating a really nice heat map implying concentrations, in this case, of higher precipitation values. So this density mapping tool works in many, many different ways for a multitude of different applications. This is just, as I said, one example. I have time for one more quick scenario before we wrap up. And again, for the umpteenth time, I'm going to download my data. I'm going to load one final layer. This brings us kind of close to home. I'm going to load up some imagery of the area in which our building is located, right here along the Kennebec River in the state of Maine. And I'm going to go through and import a final file. The file I'm going to import is a JPEG. You'll see the standard file, open data file option, and the JPEG is right here. Now, before I do this, I should kind of let you know what this JPEG is. This is actually a photograph that was taken. It was actually taken with my my phone or my camera. I happen to have enabled GPS at the time, so this particular image actually has some location information embedded in the EXIF data. In other words, the lat long values have been attributed to the image. The image knows where it belongs. If you have an iPhone, or if you have an Android phone, or if you have any type of picture capturing device that allows you to embed the coordinates, you can use the function I'm about to show you. Because when I click open in this case, what it does is it places an icon right at the position at which that photograph was taken. It all happens automatically. Now, we have imported JPEGs in different contexts. For instance, if I have a scanned map that I want to register, you'll not see the result like this. It will ask you if you want to rectify it, and you're given the option to position points to rectify that image. In this case, Global Mapper recognizes the inherent XY values that have been placed within this file and precisely plots the point at that location. The really cool thing is now my info button from the toolbar doesn't just show me attributes, but actually pops up the image itself. And we'll end our session with a very nice view of our company building here along the river in Hallowell, Maine. I have to tell you that today it looks a lot different. We have a lot of sleet and snow falling right now, but this is what it looked like earlier in the summer, I guess. So importing images, if you have a collection of photographs and you want to catalog where they're from, you simply import them. Global Mapper will do the rest. It will automatically plot the points at their precise location based on those recorded coordinate values that are embedded in the photograph, and then you have a map-based interactive photo album that you can browse your photographs based on the location at which they were taken. Once again, I am going to go back to my checklist and make sure we covered everything. As you can see, we covered geocoding, talked about catalogs and grouping, elevation areas. We used our contouring tool. A very brief introduction to scripting, certainly something that you can explore now that you know the foundation of scripting. It's a very, very powerful tool that allows you to interact with Global Mapper without actually looking at the interface very often. Density mapping, we looked at land cover. We did talk a little briefly about blending, and vectorizing slope data, where we created our areas based on defined slopes, and then the etc. Thank you for attending. Thank you for your interest in this latest Global Mapper webinar. As I always do, I've provided some contact information here. Our website, obviously. The website, by the way, does provide, if you go to the support link, it provides a link to all of our previous webinars. If you didn't have an opportunity to sit through last month, you can go revisit it at any time. It's available through a link on our webinars page. The Global Mapper Forum, as I've said in the past, I do want to make sure you're aware that the forum is an excellent resource for finding out about the functionality of the software or for posting your own questions if you're having some problems. I encourage you to register. And when it comes time to order, go ahead and send an email to the folks at GM Support, GM Orders. Or if you're interested in expanding on what we do in these webinars, maybe personalizing a little bit for your company, please feel free to send a message to our training inbox, and we can talk to you about some of the training options that we have. Finally, before we wrap up, and on behalf of all of my colleagues here in Blue Marble, I'd like to extend all the best for the season to all of you and yours, and wish you a happy and healthy and prosperous new year. We look forward to meeting you again in the new year for our continued webinar series. Thank you very much.